Alright, so this is the next problem in the homework of, see, it's a culture of 10,000 cells, and after 1 hour, count is 12,000. We have to figure out some of the stuff. Alright, so first things first, we need to find the equation. So we need to set it up. So this is going to be exponential. Exponentials are always in this format. Uh, so as you get to the a naught 1 plus the rate to the t power. T means time, r is the rate. A naught, it just means the beginning amount, and this is just the final amount. So we have 12,000 cells, and we started off with 10,000, and after 1 hour, so after 1 hour we got 12,000. So we first need to solve for the rate, which is r. So we need to solve for r. So the way we do that is, well, we have to divide this side by 10,000. 40 to one side you do to the other. Right, so that's 1.2 is equal to 1 plus r. We keep just 1 plus r because this is to the 1 power. So first power means it stays the same. So you minus 1, minus 1. You have 0.2 is equal to r. Alright, so you know that, so the equation, so your a of t now is going to be, it's going to be 10,000 times 1.2 to the t power. Okay. Um, so go ahead. So that's the function a. Oh, it's gonna be n of t. My bad. So we only change one thing. We change this. We change that just to an n. I guess the n, stands for number. So that's cool. So we have 10,000. So n of t is equal to 10,000 to 3 times 1.2 time. All right. So now it says find the number of cells after 2 hours. So number of cells after 2 hours, well, we're just going to plug it in. So you have n of 2. So that's 10,000 times 1.2 to the second power squared. So this is, again, I don't have a calculator right now. So let's see, it's going to be 144, so 2 decimal places. And you have 1, 2, 3, 4, so it'll be 1, just 2 more. So it'll be 14,400 cells after 2 hours. So after 2 hours, you have this much. That's part B. So now part C says after, oh come on, some shit. After how many hours will the number of cells double? Alright, so we want to double it. So now this doesn't really matter. So we know it's going to double it. So let's say we start with 1 cell. You just want to double that. So this will be 1.2 to the t power. So now we need to solve for t. Now to get rid of the base, and this is going to be exponential, right? This is exponential. To get rid of exponential, we need to do the natural log. Or you can do a log. It doesn't really matter. So I can do the same thing to both. But the thing is to mainly use natural log. But you can use log base 10, and it still give you the same answer. It doesn't matter. So it's just we got to use the natural log. So by that I mean, so this is going to be, so we're going to take the natural log of both sides. So it's the natural log of 2 is equal to the natural log of 1.2 raised to the t. So now you have to remember one of your rules of logs. So when we have log of a number raised to an exponent, it's the same thing as saying the exponent times the log of the base. So this becomes natural log of 2 is equal to t times natural log of 1.2. Alright, so now you just got to divide. So how you got to get t by itself. The best way to do that is just to divide by the natural log of 1.2. All right, so you have t is equal to the natural log of 2 divided by the natural log of 1.2. And that, I don't know what it is. So hopefully you have your calculator, and yeah, we'll just to plug it in. All right, cool. Now let's move on to the next one. Oh man, I can't see. Let's see. Oh, that's too much. But whatever, that works too. So we're going to solve for this. So we have 2 raised to the 6x minus 5th power. So 2 raised to the 6x minus 5th power. This thing is really weird. That is equal to 1 over 10 to the 24th power. Alright, so when solving for these, the number one rule is to get them to have the same base. So must have same base. So we need to have the same base. So this means, so this is the base 2. So that means we need to get this into a base 2. Crap. Stop. So we need to get this in base 2. So if it says the fraction, we know it's going to be a negative. So we, let's see. So the negative, let's figure this stuff out. So this goes 2 to the first is 2, 2 to the fourth, second is squared, is fourth, 8, 16, 32, that's 64, that's 128, oh Jesus, that's 16, 4, 5, 256, and then double that, that's going to give you 512, and that's going to give you 1024. So this is to the first power, second power, third power, fourth, fifth, sixth, seventh, eighth, ninth, or 10th power. So 1 over 10 to the 24 is the same thing as saying 2 to the negative 10th power. You can go ahead and just plug that into your calculator. Should be correct. Again, I don't have a calculator, so I can't do this. Let me just double check because I don't trust. I'm kind of tired. So I think, yeah, it is right. Yeah, alright, cool. So now since they have the same base, so now we can just set the exponents equal to each other. So that means, since we have the same base, we should set the exponents equal to each other. So now all we gotta do now is just solve for x. So that 6x minus 5 is equal to negative 10. So you do, what are you gonna do? You're gonna do plus 5, at 6x is equal to negative 5. So that x is equal to negative 5 over 6. And that is your answer. And that's it. Pretty simple. Alright, let's do the next one. So the next one is 7 raised to the x squared minus 3x minus 2 power. So 7 raised to the x squared minus 3x, right? I have bad memory. 3x minus 2. That's equal to 49 to the 4th power. Alright, so again, we need to get in the same base. So, since this is a 7, we know we kind of have to get this into a base of 7. Well, 49 is 7 times 7, right? 7 times 7 is the same thing as saying 7 squared. So we will write this as 7 raised to the x squared minus 3x minus 2 power. Instead of writing 49, we're going to write 7 squared. 7 squared, and we cannot forget this 4th. So now remembering our exponential rules, if you have an exponent and then raise it to another exponent, you have to multiply these exponents. So now we're going to have 7 to the x squared minus 3x minus 2 power is going to equal 7 to the 8th power. Alright, so now again, since the bases are the same, you can just set the exponents equal to each other. So we have x squared minus 3x minus 2 is equal to 8. You can just plug this in your calculator, plug this in y1, plug this in y2, and you do second calculate 5, which is for intersect, and hit enter, 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 and it'll give you some answers. But so I don't have a calculator. I'm gonna do this a long way. So we're gonna take the 8 to the other side to have it equal to 0. So we're gonna have x squared minus 3x minus 10 is equal to 0, and this is gonna be factorable. So we factor this out. Ooh, man, I'm gonna pat it sideways. That's why it's working out crazy. All right, so we have 7. So we know it's gonna be 5 and 2, but one of them is gonna be positive, one's gonna be negative. Since this is negative, we know that the bigger number has to be negative as well. So x squared minus 3x minus 10 factors out to x minus 5 and x plus 2. So this is equal to 0. So that's equal to 0. So we know by the zeroth property law, x minus 5 is 0. So we know x is equal to 5. Or x plus 2 is equal to 0. And x is equal to negative 2. So either one of these is correct. X could be 5 or x can be negative 2. Okay? So again, the main thing is to get them to the same base. They must have the same base. So let's go ahead and let's do C. So we have log of x plus 2 plus log of x minus 1 is equal to 1. So now for this one, you need to remember the rules for logs. So now when you are adding logs, it is the same thing as multiplying. So log of AB, this parenthesis you can tell, it's the same thing as saying log of A plus log of B. So log of x plus 2 plus log of that, so it's the same thing as multiplying it. So log of x plus 2 times x minus 1 is equal to 1. Alright. So you go ahead and just do this out. So you have log of x squared plus x minus 2 is equal to 1. So just like in the last page where we said when you have an exponential, you must use the log to get rid of it. So now we have to do the opposite. Now to get rid of a log, we have to use an exponent. So with this, we are just going to raise everything to the 10th power. So we're going to raise everything to the 10th power. So 10 raised to the log of x squared plus x minus 2. These two cancel. You're just going to be left with x squared plus x minus 2. And a 10 to the first is just 10. Alright? Alright, so now, again, you can plug this into your calculator to get your two answers. But again, I don't have my calculator. So we're going to do it the long way. So you're going to set it, you have to set this equal to 0. The way to do that is you have to move the 10 to the other side. So you have x squared plus x plus x minus 12 is equal to 0. Alright, so now we have to factor. Alright, so now I did the last factor pretty fast, so let's do this one the slow way. So again, factoring is pretty much, no matter which way you do it, is always going to be guess and check. There's no ways around it. There's other ways that make it look more organized or makes it look pretty, but you're always just guessing and checking. Instead of wasting time and drawing the eggs, remember what goes where, doing all this crap, we don't have to do any of that. Just do it the old-fashioned way. There's nothing wrong with it. It's worked for years. So we need to find the factors of negative 12. That will give us 1. So the obvious ones are what? Negative 6 and 2, 6 and negative 2. Alright, so we know this is not going to be anywhere near 1. So you have to think to yourself, all right, the number needs to be at least one number away from each other. At most one unit away from each other. So what times what is going to be 12? They're pretty close. Well, that's just 3 and 4, right? 3 times 4 is 12. They're 1 unit apart, so we know it's going to be 3 and 4. So now you have to remember, all right, well, since this is positive, the biggest one has to be positive. So our factors will be negative 3 and 4. So you have x minus 3 times x plus 4. That's going to give you 0. Alright, so then, again, it's either going to be x minus 3 is equal to 0, which gives us x is equal to 3, or x plus 4 is equal to 0, and x is equal to negative 4. So it's going to be one of those two. Those two are your answers, but again, x is going to be one number. So it's this one or that one. Alright? So for these, you have to remember your rules of exponents, your rules of logs to solve for these. But again, when you're doing exponentials, you have to remember to get them in the same base. They must be in the same base. For logs, you just use your log rules to combine them, and then raise it to the 10th power or raise it to the e power if it's a natural log, and then you should be done. Alright, cool.